Well, here for lesson 23, in the notes prior to this, there's definitely some key concepts you want to look into. So it's really going to talk about those x-intercepts and really what's happening at the graph of the x-intercepts, depending if the graph's going to cross through it or if it's actually going to turn and just touch right there and change directions. Okay, so there's definitely some points above, but really lesson 23 is all about is this rational roots theorem written right here. And the rational roots theorem basically is a way to help narrow down all those numbers that we're going to try out in the box when we use synthetic division. Okay, the key with rational roots theorem just basically says is that when your polynomial is written out in general form, which is term by term by term, and it's in descending order, then all those numbers that we can try out in the box are always going to be the factors of this last number divided by the factors of that leading coefficient. Okay, and if that last number, the number without a variable, is not there, remember that's 0. Okay, but it's always going to be the factors of this last number always divided by the factors of your leading coefficient. And whenever you kind of pair those up, those are actually the potential numbers to try out in the box. So it kind of helps narrow down some things a little bit. Okay, so let's take these concepts, everything in the notes leading up to this point and right here, and let's try example number 1. Starting out right here, all we want to basically do is just we're just practicing factoring our polynomial. So if I write f of x is equal to, and I want to factor this, it looks like 3x and x, and then we have 2 and 1. It looks like if we put the 2 in the back and the 1 in the front, we want a total of a negative 5, so we'll maybe make that a negative right there and then a positive right there. Okay, so there is your function written in factored form. Now normally you're sitting there going, hey, we're done, right? That's factored. Well, technically, when you write your polynomial in factored form, really how they want it as is like f of x is equal to x plus or minus a number, and then x plus or minus a number. It's always just x by itself. We don't have, in other words, a coefficient in front of that. Okay, so going back to these parentheses, the second parentheses, that one's good to go. We need to actually work with that first parentheses because I don't need 3x, I just need x by itself. Okay, so if I factor out the 3 from that first parentheses, then what do I need to multiply 3 by in order to get 1? Remember, anything times its reciprocal is always 1. So 3 times x is 3x, and 3 times a third is 1. And then have the x minus 2. And this is technically in factored form. So we're going to go with that as our final answer. Okay, so just kind of watch out for that. Let's try this again with example number 2. So we want to write this function also in factored form. So the first thing that I see that I want to do is pull off an x first of all. So f of x is equal to x times 12x squared plus x minus 1. And then we go in there to kind of finish factoring a little bit. Then looks like I'm thinking probably 4x and 3x. If I'm wrong, then what I'm going to do is come right back to this point and change it to 6 and 2. Okay, the only factors of 1 are 1 and 1. One's got to be positive and one's negative. Well, I'm going to want the outside to be positive, so that way I get 4 minus 3 will give me that 1, and then negative 1. Okay, so it looks like I've got 2 cases here. So I need both of those just to be single x's. I don't need them 4x and 3x. So I'm going to have to factor out a couple things. So let's write it like this. Okay, we've got x times, if I factor out the 4, then that's going to leave me with x minus a fourth. Just double check. 4 times x is 4x. 4 and a fourth is 1. And then times, if I factor out a 3, then that will leave me with x plus 1/3. Okay. So let's see, we basically have several things multiplied together so we can combine parts of them. So f of x is 4 times 3 is 12x times x minus a fourth and x plus a third. And by having it really in this kind of factored form, you can right away see what the x-intercepts are. Coming from here, the front, I know x equals 0. Coming from in here, I know x is a fourth. And then coming right here, x equals negative 1/3. It's just like, yeah, I can get it when they're in this form over here, but it's just so much more obvious when it's in this fully true factored form. Okay, so let's go to example number 3. With this one, we just want to find the maximum and minimum number of roots for this polynomial. Well, up above in your notes, it says that as long as your polynomial has at least one x variable, which it does. You know, it's got 26 sitting here, 70, and then 5. So as long as you at least have 1, then the minimum number of roots is always going to be 1. So the minimum is 1, and the maximum is always your degree. So you just have to watch out for this. In this case, it's 70. So it's just written out of order, but pay attention because the exponent here is 26, and then 70 and 5. So obviously the highest powered, if we wanted to write this in true general form, you really would write negative 4x to the 70th plus x to the 26 plus x to the 5 minus 1. And that's true general form in the sense of it goes in descending order. But now you can see really that the maximum is at 70. So not really a hard concept, just something you just got to watch out for. Okay, so let's try example 2. With this one, they're just giving us pieces of information. We want to write the polynomial that has 0 as a root, that's multiplicity 5, and 2 as a double root. Okay, so what that's basically saying is if I wrote out all my x-intercepts, x equals 0 is going to happen 5 times. Okay, so 1, 2, 3, 4, 5, and then it has 2 is a double root, so that happens twice. So all in all, technically, I should have a degree equal to 7 because I've got the 0 happening 5 times, the 2 happening twice, so technically kind of 7 of these. So let's see what we can do. Well, the first step here, is make sure everything's set equal to 0. So the first 5 are good. These ones we got to chunk on over. So x minus 2 equals 0 and x minus 2 equals 0. Okay. After that, the next step is to take everything that's on the left side of these and multiply them together. So x times x times x times x times x times x minus 2 times x minus 2 is equal to 0. Okay, and start right here. If you want to double check, start right here. If all of this was multiplied together and I asked you to find the x-intercepts, wouldn't you set each part of the product equal to 0? Of course. And that takes you right back to where you were. Okay, so now to finish this up, all we have to do is multiply this out. So obviously this is x to the 5th. And then when I FOIL these two parentheses, you'll get x squared minus 4x plus 4 equals 0. Okay. And then distributing that x to the 5th in there, you'll get x to the 7th minus 4x to the 6th plus 4x to the 5th equals 0. Okay, and if we just kind of want to write this, if you want to write it in polynomial form, you can say, f of x is equal to x to the 7th minus 4x to the 6th and 4x to the 5th. Okay, now as a check, if you wanted to, what you could do is pretend to start right here, and if I asked you to factor this, okay, the first thing you would do is pull out an x to the 5th, right? Which would be pretty much this step right here. Pull out the x to the 5th, and then write it as x squared minus 4x plus 4. And then from there, if you were going to factor that, that would be then x to the 5th times x minus 2, which is taking you right back to that step. And then finish solving that out. You go x to the 5th equals 0, or x equals 0 5 times, and then x minus 2, each of those equal to 0, or x equals 2 twice. So it's just kind of a backwards forward process. But this front term right here can just definitely reiterate the fact that our degree was definitely 7. Okay, so let's try example number 5, and this is where we're really going to start out with the rational roots theorem. Here it's asking us to form a list of possible roots. So when you hear the list of possible roots, right away you need to think the rational roots theorem. Okay, and first things first is check. Is this in general form? Okay, if it's in general form, which it is, because I know it goes first of all, it goes in descending order, a 6, a 5, a 1, and then your constant. Okay, so all the possible roots, so x could equal, it's going to be plus or minus, and it's going to be the factors of the constant, which we're just going to go with 3, don't worry about the sign, over the factors of that leading coefficient, which is 4. So x is going to be plus or minus the factors of 3. Well, the only things you can multiply to get 3 are 1 and 3. The factors of 4 are 1, 2, and 4. So listing this out, because you have to consider pluses and minuses, okay, so it's going to be plus or minus, and do it like this. Start with the 1 and do 1 over 1, 1 over 2, 1 over 4. This is listing out everything possible. So 1 over 1 is 1, 1 over 2 is a half, 1 over 4 is a fourth. Okay, so that one's all done. Now start with 3. 3 over 1 is 3, 3 over 2 is 3 halves, and then 3 fourths. And that right there is a list of all the possible numbers that you can try in the box when you do synthetic division. Well, how many numbers is that exactly? Well, it's 1, 2, 3, 4, 5. There's 6 positive and 6 negative, so it's a total of 12 possible roots to try out in that synthetic division. Okay, so let's look at this again with part B. Well, before I get started here, is it in general form? Well, I've got descending order, so that's great. But when I go here and try to do the possible roots, it should be the roots of the constant term. And you're like, there's not a constant term. All the terms up there have a variable with it. So how we're going to get around it is first do initial factoring. They all have x squared in common. So if I pull off x squared, you'll get 2x to the 6th minus x to the 4th minus 9. Okay, so now when we do the possible roots, we're only going to be looking at this part, because right away I know for a fact that x equals 0 is a double root, because it says x squared, so obviously it happened twice. So that's what I know for a fact, okay? So it's not necessarily a possible root, it's a definite root. It's definitely going to happen. So now to list out the possible ones, it's going to be x is equal to plus or minus the factors of 9 over the factors of 2. So let's list out all the different factors of 9. Well, we can multiply 1, 3, 3 and 3, and 9. The factors of 2 are just 1 and 2. Okay, so now combining these together, start with 1. So 1 over 1 is 1. 1 over 2 is 1 half. That's it. Start with 3 now. 3 over 1 and then 3 over 2. So 3 and 3 halves. Now that's done. Go to 9. 9 over 1 is 9, and 9 over 2. So there are, again, other than x equals 0, which you know is a definite root, these are the other possible roots to try out in synthetic division. Okay, so let's keep going on.